to do this. What about we're hearing from the atheist community, well, we can't do it in large scale amounts of chemicals. What about micro environments? If we set up smaller environments, will this make the chemistry more plausible?
No, it won't make it more plausible because still you're without the code. I mean, it's just.
Okay. Microstates. So excited? So excited. Oh, basement dweller. Hi there. Anyway, microstates is something that I brought up with Tony, and I was asking him about microstates, and then he was kind of pushing back on it. And then I asked him, well, do you think the earth was all pudding? Meaning, was it homogeneous? Was there just one environment across the entire earth? Obviously not. There were quadrillions or quintillions of microstates in which a number of different chemical reactions happened, like millions and billions of different chemicals. And they talk about asphalt or tar, and asphalt and tar is actually pretty much what we could count on. Asphalt and tar is made of thousands or tens of thousands of different carbon structures. Carbon, nitrogen, and oxygen, usually carbon and nitrogen structures, they become quite complicated. And all of these microstates were all churning about at the same time. And all that was needed was for chemistry to find a pathway through that from one state to another, where two different chemicals would get together, form a third. Those would get together, form another and another and another until we had this sort of a big mix. We don't know what was in that massive boiling cauldron of chemicals, and we're probably never going to know. What we can do is we can figure out at each step. Let me see if I can share my screen again. We want this screen. And we want this. So what we can do is figure out, so you have this massive amount of compounds, and say these two compounds will contribute to that compound. When abiogenesis researchers do something and they use purified contents, purified chemicals, they use controlled reactions. They very carefully control everything. They control how much UV is coming in. They control the temperature. They control the constituents that they start out with in the reaction. What they're trying to do is they are trying to arrive at what happens in this one step here. So basically, they're trying to figure this out. And then you figure out another one. You've got, say, these two chemicals now combine with that one, and we end up with a third chemical. So we got another step in the process. Now, if you can imagine how many millions or billions of steps or little nodes like this would be required to get to life, then you're starting to get an idea about the difficulty of figuring out exactly what happened. So. And again, the reason that I brought up pudding, which I'm going to be famous for, I'm thinking of changing my name to Speed of Sound to Pudding, guys. You'll be really excited about that. And the reason it was brought up is that you have to understand that there was no one continuous environment. There was a whole lot of stuff going on back then. This is a rather cool picture of, I forget which paper this is. Let me just be good about this. This is Origins of Building Blocks of Life, a Review by Kittadai. And I think this was done in, I'm trying to find a date, 2016. And it has a picture that sort of inspires or opens up your imagination a little bit. Let's see if I can make this a little bit bigger. So I go plus. Okay, so hopefully you can see that. There's phosphorus ores, there's geysers, there's rain, there's clouds, there's a toxic ocean just churning with all sorts of magnesium, lead, zinc, iron. mineral content extremely high because of the heat. And there's all of these different environments going on. And inside of each of these environments, if you go out and look at a pile of rocks, and just imagine how many different microenvironments are in that pile of rocks. Every crystal, every surface of every crystal has a different environment, and every crystal has a different shape. They join in a different manner. And that is going to create an immense amount of possibilities for things to happen. Now, the thing, like what I was seeing this morning, that was kind of driving me crazy, was this business of trying to calculate probabilities by saying, you know, we've got 20 amino acids to the 200th power for a 200 amino acid protein, and then multiplying that by other impossibilities. And you end up with this, you end up dividing it by 1, and you end up this extremely, you know, you got this big number, and you end up with a very, very, very tiny number, and you say, okay, it's improbable. Well, yeah. Probability is not about figuring out what happened in the past to lead causally to where we are right now. What happened in the past to lead causally to where we are right now happened. So the probability is 1. The probability that we are at this point in our lives, in the world, is 1. It happened. It doesn't matter how improbable little steps are in the past. But of course, they want to create a situation where naturalism is completely improbable and therefore required some sort of an intelligent designer, and that's why they're doing it. A naturalist would not do it that way, would not do those calculations. A naturalist understands that there are a massive amount of possibilities back here in the causal reality of the universe, all the way from the Big Bang to the formation of the solar system and the Earth and the cooling of the Earth. So we have all of this massive amount of possibility, and that's what we're looking at. And we're trying to find the pathway that life took to get to where we are right now. Now, the other thing that they do that kind of drives me crazy is they will pick this. Let me see here if I can get a better better pellet. But this spot right here, okay, life already had a couple 100 million years to get to the point where we had racemic amino acids, nucleotides, possibly some sort of membranes enclosing cells, all of that. And they'll start talking about the impossibility. And like James Tour here in this entire video is talking about how we have to have the nucleotides and the amino acids, and they have to be racemic, and they are not racemic, but they have to be all L amino acids and D carbohydrates, and we have to have exactly the right chemicals to get to life. Well, that was way out here. That was a long time after. We're looking at what's happening back here. The first thing you have to understand about abiogenesis is that you need to forget about nucleotides, amino acids, and carbohydrates exactly as we have them today. John Maddox drives me even crazier because he'll go way out here and start talking about ribosomes, you know, with 49 proteins and a bunch of RNAs, a very complex structure, ribosomes, and he'll talk about eukaryotic ribosomes. He won't even talk about the prokaryotic ribosomes, which are simpler, and you can see the progression from one to the other. So this probability game or back of the envelope calculation from which these guys on these weird creationist internet sites think that they can figure out, philosophically prove that life couldn't have happened through abiogenesis is just bullshit. Now, I say some pretty odd things, and one very odd thing I'll say is that I don't really believe in abiogenesis. And the reason for that is because I don't know what happened. And as long as I don't know what happened, it's difficult for me to believe in it. It's difficult because I don't know the exact pathway that life took. You know, I think it did happen naturally because I can't think of anything other than naturalism that could possibly exist for philosophical reasons. So I'm kind of stuck with it, but I don't actually believe in it until I see exactly how it happened. So I would have to know at least one pathway to get from this prebiotic Earth to at least the point where we have clusters in little, maybe in little pockets of rock of certain chemicals, or maybe we had some sort of a membrane that could divide and create more than one of these little critters. And these are called, I forget what they're called. Let's see, what is the name? There's a neat term for those. A progeno. Basically, life before there was a strong relationship between the genotype and the phenotype. In other words, we didn't really have a strict set of DNA or RNA in these things. There was sort of a mixture of a number of different complexes, different RNAs, and they just kept dividing. And every life form had its own phenotype, sort of, which probably wasn't too exciting. They were probably just little globules of stuff. And they kept multiplying and taking in energy, creating more chemicals because of autocatalysis, where you apply energy and the system will generate more and more of itself. And there were a number of these different systems, I'm guessing. And so we had this prebiotic world that was extremely alien. And that is the stuff that never gets talked about, those little tiny steps. Anyway, what abiogenesis researchers are doing, and thousands of them are doing it, is they're trying to find these micro steps between these micro environments. Now, I don't think Tony didn't understand what he was talking about with micro environments, and he didn't ask the question very well of James Tour, so he didn't get a very good answer. So James Tour just went on and did something else. Yeah, good point. Why do creationists never do any novel research? Pretty much all their data points come from creationism scientists. They misrepresent the data. They don't come up with the data. The reason for that is because they believe they already know the answer. Unlike me, with my disbelief in what happened, because I don't know what happened, they will insist that they know what happened. They know God did it. They've got this rotting old book that they dug out of the desert somewhere, and it tells them how everything happened. I'm afraid I don't believe in that stuff, guys. I don't believe in magical things. I don't believe in the supernatural. I'm stuck with naturalism, so I have to figure it out with chemistry. Everyone who's working on this basically is in a state of disbelief. They don't know what happened, and they're trying to figure it out. And that's why we use purified chemicals. That's why we use controlled environments, because we need to know exactly what happened. We don't want, it doesn't do us any good to put a bunch of gunk in a bowl of pudding and basically wait around for something to happen, because if something did happen, we wouldn't know what the hell it was unless we control the environment. And Anthony Maurice, I see you in my chat. For some reason, that's the way you think. And that's why I don't believe you're actually a chemist. You couldn't possibly be. Anyway, it's not science. If you know the answer, yes. I don't know what that means. I'm not sure, Sean. I didn't quite figure that out. Basically, if you know the answer to how something happened, yeah, I guess that would be science. You know, I think it becomes engineering at that point, because then you can go ahead and reproduce it. So anyway, I want to make this point that probabilities are about predicting what happens in the future, not about trying to figure out what could have happened in the past, particularly. I mean, I suppose there are applications for that, but this is not one of them. There's too many things that went on here. And you'll ought to take a look at some of these papers that are coming out on abiogenesis. It looks to be at least 1,200 of them are coming out every year. If you go back in Google Scholar, you will find a tremendous amount of information about prebiotic earth and all the different possibilities that they're looking at. So we don't know yet, right? And we're trying to figure it out. And it is going to be probably 100 years before we have the computational power and the information in chemistry and the knowledge of what the environment was in the earth, what those microstates were, in order to make any progress in this at all. I think in the next 20 years, because of the amount of money that the pharmaceutical industry is putting into it, we are going to have autocatalytic systems that create a whole bunch of unique and wonderful drugs based on protein folding. And then guys like Lee Cronin, who are working on exobiology, are going to come up with even more fascinating little molecules, because they're not restricting themselves to just the 20 amino acids that we have, or 22. They're allowing for the possibility of new kinds of biochemistry. And they're going to come up with a whole lot of wonderful medical discoveries based on that. And that is some pretty exciting research. Sorry, creationists, but studying abiogenesis is something that's really heating up right now. And billions of dollars are starting to be poured into this industry. And you're just going to be inundated with papers. Of course, you'll be able to cherry pick a lot of quotes. It'll be a lot of us saying, we don't know what happened. And you guys love when we say, we don't know what happened. Anyway, you want to stop in standing? I can send you a link. Because I'm kind of done here. I just wanted to say that bit about probability. Yeah, science keeps chipping away at it. And that's the important part. And I think we're making a lot of progress. Like when we started reading abio papers in the last 6 months, we were shocked, I think, at how many different possibilities there are that nobody's talking about. Anyway, I think I'm going to end this, guys. Hopefully, I don't really have much more to say. I'll just fumble. I'm not good at this shit. I'm sorry, guys. So anyway, I'll think of something next. And we have Saturday Night at the Atheist tonight. I have an invite out to a number of people, but Just a Walking Fish and Immutable are going to be there. So we'll see you tonight. Goodbye.